every element of set A must have only one image in set B. That is going to be known as the 1-1 function. Each element are going to be known as the pre-images, and the whole set X is going to be known as the domain set. Y belongs to Y is called as the image of the element X belongs to X. Every element of set B will be having a pre-images in set A is going to be known as the onto function. Hello dear students, a warm welcome to one and all. My name is Vibha. Vidhyaashram, the Temple of Excellence, Pre-University College, Mysuru. So in this session, we are going to talk about, or we are going to learn the topic called sets, relations and functions, which is a chapter number 2 and session number 7. Okay. So what are the topics we are going to learn under this session, dears? Let me see here. You are going to have what is a condition for a function, and then what will be the domain, codomain, and range of a function, and then different types of functions you are going to study. Let me look into the what do you mean by a condition, or what is a condition of a function here. A function is nothing but it is a function from X to Y. Here I am taking, then set X and Y be two non-empty sets, a subset of X into Y. This is important. A subset of X into Y. What is X into Y? It is nothing but the Cartesian product, isn't it? X into Y is called as a function if the following conditions are holds good. What is the following condition you are going to have? For each X belongs to X, there exists unique Y belongs to Y such that X comma Y belongs to the function. And then see, for each X belongs to X means you are going to have, this is a function which will be having the X elements, that is 1, 2, 3, and this is A, B, C, which is having elements of Y, and the function I am going to have it as F from A to B or X to Y. So this is a X and this is a Y. You are going to have it as, for their X belongs to X, see X belongs to X, there exists a unique Y belongs to Y. There exists a unique Y belongs to Y such that X comma Y belongs to the function F. That is the first condition. Next, you are going to have elements of X should not be repeated. What is that element of X? These should not be repeated. Okay, that is a condition you are having for a function. Okay, so for example, let me take here, let X will be having the elements of like 1, 4 and then 9, and then Y will be having the elements of 1, 2 and then 3. So if you are going to give it as f of X is equals to X squared, 1 squared is 1 and 2 squared is 4 and 3 squared is 9, you are going to have it as a function, isn't it? See, this is a Y is equal to X squared. Okay, Y is equal to X squared. So if you are going to have X element as, this is a X element 1, 2, 3, and then this is a Y element if I am going to have it as 1, 4, 9, and then 16 if I am going to have it as here. So and then Y is equal to X squared means you can have it as 1 will be equal to 1 squared is 1, 2 will be equal to 2 squared is 4, and then 3 squared will be is equals to 9. This is how we are going to take the elements of X here and the elements of Y here. Y is equal to X squared, isn't it? So X squared means 2 squared will be 4, 3 squared will be 9, and no element should be left out in the domain set. So what is this is going to be known as the domain set. Let me come next to after this what we are going to call these elements as and these elements as. Okay, so condition is such like for every X belongs to X, Y belongs to Y, there exists X comma Y such that in a function itself. Okay, and then relation. Now elements of X should not be repeated. This element should not be repeated. That is a condition. Next, here I have taken a notification of a function if x1, y1 belongs to the function x2 y2 belongs to the function, then we are going to have it as y1 will be is equals to y2. Okay, next if you are going to have it as y belongs to y is called as the image of the element x belongs to x. So here if I am going to take it as this is a element of, this is 1 2 3 and a b c, if I am going to take it as this is a function, and this elements are going to be known as, these elements y elements are going to be known as images, okay, and these elements are going to be known as pre-images. You have to note down this. So elements of y which you are going to get connected, that is going to be known as the images, and the element of x we are going to know it as the pre-images. Okay, so here set x is called as the domain of the function. The whole set, this whole set, each element are going to be known as the pre-images, and the whole set x is going to be known as the domain set. Understood? This whole set x, this is going to be known as the domain set. Okay, and this whole set is going to be known as the codomain set. Okay, so here y is called as the range of the function. What is the range of the function? Range of the function is nothing but the connected element. Connected element is always going to be known as the range of the function. The whole set y is going to be known as the codomain set. For example, here I have taken, see, 1, 2, 3 are nothing but the domain set elements, and 1, 4, 9, 16 are nothing but the codomain set elements, but 1, 4, 9 are going to be known as the range. What do you mean by range? The connected elements. Here I am getting connected only 1 to 1, 2 to 4, 3 to 9. These connected elements are going to be known as the range of the function. Understood? This you have to understand. Left hand side set, that means this is called the left hand side. Left hand side set is the domain set. Right hand side set is the codomain set. Connected elements are nothing but the range of the function you are going to have it as. Okay? We'll move on to the next. Consider a is equals to 1, 2, 3, b is equals to a, b, c. Let f is equal to 1, comma a, 2, comma b and 3, comma c. Let me represent this as a diagram here, and then let me know whether it is a function or not. See, the set A elements are nothing but 1, 2, 3. This is a set A, and set B elements are nothing but the A, B, C. So here I am going to have a function from A to B. Function from A to B means here f of 1 comma A means 1 is getting connected to A. Now 1 is getting connected to A, and then you are going to have it as f of 2 comma B. 2 is getting connected to B, and then 3 comma C. 3 is getting connected to C. This is what the diagram you are going to have, the function. You can see here elements of x are not repeated, and it is having a unique images. If it is having a unique images, otherwise you can say like this: no element should be left out in the domain set, and all the elements of the domain set must be having the unique images in the codomain set, because we are going to call these elements as the images. Okay, the right hand side set elements are going to be known as the images. Left hand side set elements are going to be known as the pre-images. Every element of A must have unique images in B. Every element of A must have unique images in B. That is going to be known as the function. Okay, so here this is going to be known as the function. That's it. So I think you understood this one. We'll move on to the next one. What do you mean by the domain, codomain and range of the function? Here I am going to take a definition of a function as like this. Let f from A to B be a function. That is, f is a function or a mapping. Mapping, you are going to name it as this one. Mapping, or f from A to B. Mapping to a function. From left hand side set to a right hand side set, it is a mapping, getting connection. Okay. So from A to B, the set A is called the domain. As I told you, this whole set A is going to be known as the domain set, and this whole set B is going to be known as the codomain set. That's what I have explained here. Domain of F, and the set B is called the codomain of F. Then what is the range, ma'am? Range is nothing but the connected elements are going to be known as here. The connected elements are nothing but the A, B, C. That is a range also. That is codomain also. Because what is a codomain set? The whole set B is going to be known as the codomain set. Here, codomain will be is equal to the range of the elements, isn't it? So what is a domain here? Domain is nothing but elements of domain are nothing but 1, 2, 3. Correct? And then elements of codomain are nothing but A, B, C, right? And then what is the range? Range is nothing but what you are going to have, the connected elements. What are the connected elements? A, B, C only. So you can check over here. You are going to have it as codomain is equal to the range, isn't it? Yes. Sometimes codomain will not be equal to the range. Okay. Sometimes codomain will be equal to the range. Got that? We'll move on to the next one here. This set consisting of all the images is called the range. All the images means where the connected element goes. So of F, which symbols is written as F of A. What is F of A? Here you can check out. F of 1 is nothing but A. Similarly, F of 2 is nothing but B. F of 3 is nothing but C. What is this 1, 2, 3 in which? In the set A. So that only F of A is going to be known as the Y. Otherwise, if you are going to take this one as X and if you are going to take this one as Y, you are going to name this as Y is equal to F of X. This you have to remember. Y is equal to F of X is nothing but the range of the function. You are going to have Y is equal to F of X means range of the function. Connected. Yes. Okay. Here I have taken an example. F is equal to 1, A, 2, B, 3, C, 4, D. What is the domain of the element? The whole set A. This 1, 2, 3, 4 are going to be known as the domain. A, B, C, D are going to be known as the range. What is a codomain? Codomain is also a range only. A, B, C, D only. If you want me to write the diagram, I can write it over here like this. A, you are going to have it as the set A elements, set B elements. Dear students, you can call this one as set X also, set Y also. It up to your convenience. Here I have taken it as set A and set B. Okay. So here I am going to write the first element. See, the first element, you are going to have it as always the first element are nothing but the domain set. The second element are nothing but the range. So here we are going to write it as 1, 2, 3, 4. And then here, the second elements are A, B, C, D. So here 1 is getting connected to A. See function. I am writing an arrow mark which is going from left to right. Okay. F from A to B only. Mapping from A to B. Set A to set B. 2 to B. And then 3 to C. And then 4 to D. You can check over here. No element is repeated of what is that set A. And then all the elements are having unique images in set B. That is a function always. Okay. Yes. We'll move on to the next. F of A is contained in B. What is F of A is contained in B means you are going to have F of A is a subset of B always. You can check over here, dear students. See, A, B, C is nothing but F of 1, 2, 3. Correct now? Similarly, you can check over here. F of 1 is 1. F of 2 is 4. F of 3 is 9. But one element is left out here. So therefore, you can consider it as F of 1, 2, 3 is nothing but it is a subset of F of what is that? This codomain set. Always range is a codomain. What is F of A? F of A is nothing but the range. Okay, range. What is B? B is nothing but the codomain set. Codomain set. Always range is a subset of the codomain set. Okay. So next, every function is a relation but converse will be not true. See, every function must be a relation, but every relation may or may not be a function. For this simple example, I like to give you. if you are having the 20 members in a family, you may or may not celebrate a function, correct? Because there are 20 people. For a function, if 20 people are there, you can celebrate in your own. That means joint family. Suppose if you are having only 2 members in a family, then if you want to celebrate a function, means you are going to invite? You are going to invite what? The relatives. Their relatives will come. So if you want to celebrate a function, relations must be there. Relation means you can invite also friends, isn't it? You can invite also relatives. So here I am talking about the relations and functions. I am going to particularly concentrate on what? Relatives. Okay. If you want to celebrate a function, a big party in your home, you are going to call the relatives. Suppose if you are having a joint family, that means if you are having all the relatives in your home itself, you may or may not celebrate a function. Therefore, every function must be a relation. Every function must be a relation. Relation may or may not be a function. That is an example I have given. If you are having a relatives, you may or may not celebrate a function. If you are having a function, you must call a relatives. That is a simple example I can take you to understand for this sentence. Understood? Yes. Okay, we'll move on to the next one. Types of functions here. Into functions, the mapping f from a to b is called the into function if there exists at least one element of set B which is not an image. That is called, or which is no pre-image in the set A. Symbolically, we write it as f from A to B. Okay. So here, into function means you are going to have it as function f. This is a function, you are going to have it as 1, 2, 3, 4, and this is A, B, C. F from, this is a set A and this is a set B. I am going to call it as f from A to B is called as into if there is at least one element of set B which is not an image. For example, here a D I am going to take it as 1 is getting connected to A, 2 is getting connected to B, 3 is getting connected to C. D is not having a pre-image, or there is one element is left out in the set B is going to be known as the into function. Understood? So here no element should be left out in the domain set, but any one or more element is left out in the codomain set, then it is going to be known as the into function. That's it, dears. Yes, we'll move on to the next one. Many to one function. What do you mean by many to one function means? See, the left hand side said these elements, these are going to be known as the pre-images. Pre-images, correct? That is 1, 2, 3. And these are elements A, B, C, D are going to be known as the images. Images. This is a function A to function B. I am going to take it as f from A to B is a mapping. What do you mean by many to one means every element of set A, every elements or a 2 or more element of set A can have only one image in set B. 2 or more element of set A, 2 or more element of set A must have only one image, can have only one image in set B is going to be known as the many to one function. By a definition, I am going to define like this. The function f from A to B is called many to one function if different elements of a set A have the same image in set B. That means 2 or more elements of set A have same image in set B. For example, here set A will be having 1, 2, 3 and set B will be having A, B, C, D. Suppose if you are going to have from set A to set B the function 1 is getting connected to A, 2 is getting connected to A itself, 3 is to B. See, you can have like this. See, 2 elements of a set A is having only one image in set B, that is going to be known as the many to one. You can define here itself many to one. It is going like this, many to one. Are you getting? Many to one. Many can be any elements of set A. All the elements of set A can have only one image in set B. For example, like this I can show you. See, 1, 2, 3 can have only one image is A here. A, B if you are having. Set A to set B if you are going to have the function. 1 can be getting connected to 2, 3 can be getting connected to A, 4 can be getting connected to A. Many to one. Okay, many elements of set A having one image in set B, it is going to be known as the many-to-one function. Yes. Next, we'll move on to the function 1-1 function. 1-1 function is also going to be known as the injective mapping. Okay, here what do you mean by 1-1 function? 1-1 function means every element of set A must have only one image in set B. Every element of set A must have only one image in set B. That is going to be known as the 1-1 function. How we are going to define in a definition? A function f from A to B is said to be a 1-1 function if different elements of set A have different images in set B. There, different elements of set A have only same image in set B is many-to-one. Different elements of set A must have different images of set B, that is unique images of set B, is going to be known as the 1-to-1 correspondence or 1-1 function or injective function, injective mapping. So here I can take symbolically, we are going to write it as if f of x1 is equal to f of x2 implies that x1 is equals to x2 for all x1 comma x2 belongs to the set A. This is to prove the 1-1 function. How 1-1 function will look like, dears? You are going to have like this 1, 2, 3, here A, B, C. Here I am going to take is the function A to B, 1 to A, 2 to B, 3 to C. You can see every element of set A has a unique images in set B. That is going to be known as the 1-1 function. Okay, 1-1 function. Got now? Next we'll be moving. Suppose if one element is left out here, it is going to be known as the into function. That you have to remember. All the elements of set A is connected to only one element of set B is going to be known as the, what is that? The many-to-one function. Understood? Yes. We'll move on to the next one. What they have asked, onto function, or what they have given onto function means the mapping f from A to B is called as an, if every element of set B is the image of some element of set A. So that means every element of set B will be having a pre-images in set A is going to be known as the onto function. So what is that? I have taken example here, f of x is equal to x square for all x belongs to the natural number, but x should be lesser than or equal to 3 I have taken. Let me write down here. What is that? Let x is equals to 1 because natural number will start from 1 itself. Let me take here f of 1 is equal to 1 squared is equal to 1. Similarly, x is equals to 2. F of 2 is equal to, put x equal to 2, it will become 2 squared which will be is equal to 4. Similarly, x will be equal to 3 because they have given lesser than or equal to 3. Equal to 3 also we have to take. If they have given lesser than 3, we should take only 2 elements, that is 1 and 2, right? So lesser than 3. So f of 3 will be is equal to 3 squared which is equal to 9. Therefore, what you are going to have it as? Let me do by the diagram. This is a set A and this is a set B. The function here you are going to have 1, 2, 3 the elements. Here you are going to have 1, 4, 9 are the elements. 1 to 1 is getting connected, 2 to 4 and then 3 to 9. Understood? You are going to have it as, see, whenever codomain set is equal to the range, I already told you this is going to be known as the domain set and the right hand side set is going to be known as the codomain set. Connected elements are going to be known as what? Range. Yes, you are right. So therefore, whenever codomain set is equal to the range, it is going to be known as the onto function. That you have to remember. Codomain set is equal to range of the function, is equal to range of f. Then it is going to be known as the onto function. Otherwise, you can remember like this. All the elements of set A must have pre-images in set B. Sorry, all the elements of set B must have pre-images in set A because I have taken here mapping from A to B. Okay. So every element of set B must have a pre-images in set what is that? A. That is going to be known as the onto function. Otherwise, this is a definition for onto function. Whenever codomain equal to the range, it is going to be known as the onto function. That's it, dears. Yes, we'll move on to the next one. Bijective function. What do you mean by bijective? When the function is both 1-1 and onto, it is going to be known as the bijective. What do you mean by 1-1? Every element of set A must have unique images in set B. What is onto? Whenever codomain is equal to the range, it is going to be known as the onto function. So this is only, you can take it as 1, 1 and onto function. See, 1, 1. 1 to 1 correspondence is there. Codomain set equal to the range, it is going to be known as onto function. If the function is both 1, 1 and onto, see, a function f from A to B is said to be bijective. If the both 1, 1 and then onto function, then it is going to be known as the bijective function. Here, 1, 1 and onto function, let me take an example. F of 1 equal to P, F of 3 equal to R and F of 4 is equal to S. Therefore, I can write it as, what are the elements? These. This is a X element. F of 3, F of 2, F of 4. Let me write it as 1, 2, 3, 4. And then let me write it as, these are all the set B elements. P, Q, R, S. So, therefore, 1 is getting, F of 1 is P, F of 3 is R, F of 3 is R, and then F of 2 you are going to have it as Q, and F of 4 you are going to have it as S. See, you can check over here, there is 1 to 1 correspondence and codomain set is equal to the range, isn't it? So what is the domain elements? Domain set elements are 1, 2, 3, 4, 1, 2, 3, 4. What is the codomain? Codomain set elements are the whole set B. One, that is P, Q, R, S, correct? What is the range? Range is nothing but the connected element. You can see, dear students, the connected also P, Q, R is only. See, you can check over here. Domain set, codomain set is equal to the range. Therefore, it is onto function as well as it is 1, 1 function. Therefore, this is going to be known as the bijective function. Dear students, 1, 1 function is going to be known as the injective. Onto function is going to be known as the surjective. Both injective and surjective get together gives you the bijective function. Okay? Yes. We'll move on to the next one. 1, 1 and into mapping. What do we mean by 1, 1? 1, 1 means you are going to have 1 to 1 correspondence. Into means one element is left out in the codomain set is called into. So how we are going to define that one? A function f from A to B is said to be 1, 1 and into function if the range of the function is subset of the B. Range of the function is subset of B means whenever range will be a subset. Here range is equal to the codomain. Codomain set is always a subset. Whenever range is not equal to the codomain, then it is going to be known as the 1, 1 and into function. One element is left out. For example, here I can take it as, see, there must be at least one element of a set B which is not the image of the same element of set A. That's what. Codomain element will be not having any one element, will be not having the images in set A, that is going to be known as the 1, 1 and into function. So here f of 1 equal to A, f of 2 equal to B, f of 3 is equal to C. Suppose for example here 1, 2, 3, here A, B, C, D. Okay. So f of 1 equal to A, correct? F of 2 is equal to B, and then you are going to have f of 3 is equal to C. D is left out here from A to B, therefore this is a function called 1, 1 and into function. Any one element is left out in the codomain set, that is range is a subset of a codomain. What is the range here? Our domain set is nothing but, let me write here domain elements, that is 1, 2, 3, 1, 2, 3. What are all the codomain? Codomain are whole set B. Codomain elements are the whole set B is A, B, C, D. A, B, C, D. What are all the connected elements? Range. Range, connected element is nothing but A, B, C. Correct? See, A, B, C are in codomain set. Therefore, range is a subset of the codomain set. Then it is going to be known as 1, 1 and into function. That's it, dears. Yes, we'll move on to the next. Many to one and onto function. What is many to one? Two or more elements of the set A having one image in same image in the set B is called many to one. Onto means whenever the codomain is equal to the range, it is going to be known as the onto function. Let me see here. A mapping f from A to B is said to be a many to one and onto function if range of the function is equal to B. That's it. If whenever the codomain set is equal to the range, it's going to be known as the onto function. But many to one means two or more elements of set A must have the images in same image in set B. It is called many to one. See, that's what here, two or more elements of set A have same image in set B. For example, here I am going to take it as natural numbers or the integers. Here f of minus 1, 1, minus 2 and 3. See, I am going to write the elements are minus 1, 1, minus 2 and 2. And then here I am going to write C1, 4 if I am going to write it as. So minus 1 is getting connected to 1 itself, correct? This is a mapping from A to B. And then you are going to have it as 1 is getting connected to 1 only. You can check over, dear students, many to 1, many to 1. And then minus 2 whole squared is nothing but 2 only. 2 squared is also is nothing but 4 only, correct na? So here many to 1, but no element is left out in the set B. It is called onto function. The domain of the function is minus 1, 1, minus 2 and 2. Range of the function is connected element 1 and 4 only. Codomain set is 1 and 4 only here. Therefore, this is going to be known as many to 1, and then codomain equal to the range means it is onto function. That's it, dears. Yes. Okay, we'll move on to the next one, constant function. Constant function means the k which is getting connected to only one constant is going to be known as a constant. Here f from A to B is going to be known as f of x equal to k for all x belongs to A and k belongs to B. K belongs to B is like, here I have taken if each and every element of A belongs to A mapped onto single element, only one element, that is a constant element, that is going to be known as the, what is that, constant function. What is K belongs to what? A codomain set B. Then F is going to be known as the constant function. See, here I have taken A element here. This is a B. B element is having only one element which is nothing but the K. Here 1, 2, 3, 5 I am going to have. 1 is getting connected to K. 2 is also getting connected to K. 3 is also getting connected to K. F of A is equal to K. It is going to be known as the constant function. All the elements are getting connected to only one element, that is a constant. K can be anything. You are going to define it as, it is going to be known as the constant function. Yes, we'll move on to the next one, inverse function. Inverse means f from A to B, B 1, 1 onto function from A to B. Then for each B belongs to B, f inverse of B will be is equal to A exists, and it is unique that f inverse ulta, f inverse means ulta, from B to A is a function defined by f inverse of B is equals to A if and only if f of A is equals to B. What is f of A? F of A is equals to B. F inverse means you are going to have ulta, B to A. That is going to be known as the inverse function. Note, if f is a bijective function, then f inverse is also a bijective function. Always invertible function must be a bijective function. Bijective function means it must be both 1, 1 and onto function. Then only we can say it as it is a inverse automatically exists. For example, if I am going to take it as f of x is equal to x squared, from natural number will start from 1. For x is lesser than or equal to 3 only, let me take it as 1, 2, 3, and then here I am going to have 1, 4, 9 only. You can observe here, see, 3 to 1 to 1, 2 to 4, 3 to 9, because f of 1 squared is 1, 2 squared is 4, 3 squared is 9 only. If you take it as this is A to B, correct? What is B to A? B to A is also 1 is 1, 4 is 2, that is square root of 4 is 2, square root of 9 is 3. If you take it as ulta also, you are going to get the same answer. That is going to be known as f inverse. That is a invertible function. So therefore, invertible function means f must be a bijective. Bijective function means f is both 1, 1 and onto function. Understood, dears? Yes, we'll move on to the next one, composite function. Composite function means you are going to have here 3 functions. So here I am going to take it as let A, B and C be any 3 non-empty sets. Let f from A to B, G from B to C be any 2 function. Then how I am going to define the, what is that, composite function? Define a function g of f from A to C as g of f of A is equal to g of f of A. You can take it as for all A belongs to A. Since f of A belongs to B, g of f of A belongs to C, such that g of f so obtained is called the composite function of f and g. Similarly, we can define a composite function like that. F of g of x is equal to f of g of x. Let me write it here, dears. See, this is a f function. This you are going to have it as f from A to B and then g from B to C. Okay, this is a f function. This is a g function. Here I am going to have it as f from A to B. See, these are all the elements of f from A to B. This is a, this is a B, this is a C. If you are having f from A to B, f from A to B is a function, and then g from B to C is a function. Okay, then f from A to C, you can observe here what I am taking. A to C is going to be known as the bijective function. Suppose if I am going to call this one as f of A is equals to B, we are going to call it as f of g of A is nothing but the C. That's what I have taken here. F of g of f of A. G of f of A is going to be known as the C function. You are going to have it as, okay. So this is going to be known as the composite function. Understood? So here I can take the elements, here also elements, and here also elements I can take it as. If f from A to B, g from B to C, then what is that you are going to have? G of f means g of f is going to be known as the function from A to C. A to C. That is going to be known as the composite function. Okay, here you have to notify that f of A belongs to B. See, f of A belongs to B as I told you here. F of A, f of 1 is 1, f of 2 is 4, f of 3 is 9. F of A is nothing but all the elements of B is going to be known as the f of A. What is g of f of A? G of f of A is nothing but all the elements of C is going to be known as the g of f of A. That is a composite function. Combining the function of two gives you the other function. Okay, so here I have taken g of f of A that belongs to C. Got? So that is what the composite function. Next we'll move on to the identity function. Identity means f from A to A is said to be an identity function. F of x is equals to x for all x belongs to A. It is symbolically written as IA. That is IA f from A to A. Suppose if you are having only one, A is equal to 1, 2, 3 and mapping from A to A. F from A to A is going to be known as the identity. I can write here 1, 2, 3. I can write it here 1, 2, 3. 1 is getting connected to 1. Okay, this is going to be known as F from A to A. If you write it ulta also 1 to 1, 2 to 2, 3 to 3 only it should connect. A to A only it should connect. That is called what? The identity function. Okay, yes, I think you understood this session, how the different types of function, what is a domain and what is a range. Range means connected. What is a codomain, and how we are going to define the different types of the functions. So in the next session, we'll be moving on to solving the problems based on this rules. So thank you, dear students.